Hi, I'm Mia Burns, and I'm doing a presentation on 3D bioprinting. So what is 3D bioprinting? It's technology where bioinks mixed with living cells are printed layer by layer to construct natural tissue-like 3D structures. It's closely related to regular 3D printing, and so I 3D printed like a little brain, if you want. So there's three major steps in the process for bioprinting. The first step is scanning and imaging, like MRI, and then you can use CAD to design the print. The next step is the actual printing, and then the last part could involve UV cross-linking, which is when you put the structure under UV light so that it solidifies. There are different types of bioprinting, and each one is best depending on what you're trying to print. So inkjet, it ejects the drops of bioink onto the plate. Then there's stereolithography, which is when hydrogel is in a bath and ultraviolet selectively solidifies the polymer layer by layer. And then there's laser-assisted bioprinting, which is when you use lasers to push the droplets of bioink out. And then last step is extrusion, which uses pneumatic and mechanical screw plungers to dispense the bioink, and it will generate a continuous cylindrical line. So next, what are biomaterials and bioinks? Biomaterials are materials that mimic what the body does, and bioinks are made of natural or synthetic biomaterials mixed with living cells and growth factors. Biomaterials can be classified into two major types. Natural polymers, like gelatin, alginate, and hyaluronic acid, are water-soluble and can be dissolved to form hydrogel. In the hydrogel state, they are more fluid and can be printed layer by layer. Natural polymers are able to provide an environment that helps facilitate cell activities. Synthetic polymers are used because they are more chemically and mechanically consistent, and the mechanical properties are better. Because they aren't great cell environments, biomimetic cues such as proteins are added. Polymers such as PLA, PGA, and PCL can accelerate the process of bone repair and inhibit inflammation and foreign body rejection. Synthetic polymers are also FDA approved, so it's more useful to use inside of the body. Bioprinting can be applied to tissue engineering. It can also be applied to print patient-matched devices. Bioprinting can also allow labs to test on something that truly mimics the human body. The future of bioprinting promises printing full organs, which would help with the donor organ shortages. Already, functional bladders have been printed and transplanted. Also, biomaterials encapsulated cardiomyocytes have been used to construct cardiac tissue. Here's my resources, and does anybody have questions?